Well, hello, friends. Welcome back to the car. Today, I'm going to talk a little bit about a new string class I've been working on. So, um, as I'm recording this, we have a pull request open from Linus, where he renames the current ACK string to deprecated string. And that is to make way for a new string class for SerenityOS. And it's something I've been working on for the last week or so. And the reason that I wanted to start building a new string class is because I tried to write Yacht code for SerenityOS, and the biggest pain point by far is the incompatibility between Yacht strings and SerenityOS strings, because the Yacht string class from the Yacht runtime library started as just a copy of the Serenity string class, but then we added features in Yacht to the string class that were things that I always wanted to have in the Serenity string, but they were kind of hard to introduce. Specifically, the ability for string allocation to fail and the program to sort of signal allocation failure to the caller. That was just not possible with the string class that we've had this whole time, because it assumes that allocation always succeeds. So that was sort of the main thing that made it impossible to just take the Yacht string class, bring it right over. But when I started down on this path, I thought, okay, well, if we're gonna do this thing where we replace the main string class, which is used in thousands of places in Serenity, we should make sure that we get whatever features that we want in the new string class. Let's just get them right now, because doing this again will be painful. I mean, it's already painful replacing the string class like we're doing now, and it's going to take a ton of incremental work to migrate to the new string class. But I guess I thought I would talk a bit about the features that are coming with the new string class that I think are pretty nifty. So I mentioned the ability to signal allocation failure, and in practical terms, that means that the new string class has factory functions instead of just constructors, so you can't implicitly construct the new string class just from a character literal, for example. You have to use a factory function, and the main one is called from UTF-8. And you can still pass that a string literal, but one of the things with the new string is that while the previous string was kind of ambiguous about what is really the character encoding used internally in the string, the new string class is explicitly UTF-8. So, but I'm getting ahead of myself. So what I wanted to say is that the new factory functions return error or string, and that's how we're able to use it with try macros, must macros, and it also slots perfectly into Yacht, which already automatically handles the try and must stuff. And yes, and then, as I was saying, the new string is UTF-8. Previously, we've had strings containing UTF-8, but also like Latin 1 and other encodings in various places. And we've been playing kind of fast and loose with whatever's inside the string. For the most part, it's UTF-8, but there's no guarantees. And something that makes that much worse is the fact that our old string class, now called deprecated string, hopefully by the time you see this, but we'll see, the old string class had an operator square bracket, right? So it had a subscript operator where you could index into it. And what you were indexing into was just a byte array, which in most cases is not really what you want, because if the string contains anything but ASCII, right? Anything but pure ASCII code points, byte indexing into it is probably not what you want to do. What you want to do is either you want to walk it code point by code point, which we do in many places in Serenity, but we're not great about it, and it's something we have to get better at. So you want to walk code point by code point, or you want to walk like by graphemes. So if you're writing a parser, for example, typically you would want to walk code point by code point, but if you're figuring out what you want to present visually on screen. Maybe you want to walk graphemes or grapheme clusters or something like that. And the first version of the new string class has a code points API. So you ask it for the code points, and it gives you an iterator that you can use to walk one Unicode code point at a time. And there is no like dot characters or dot characters without null termination, even, just to like be perfectly clear that there is no then there's no way to like safely access the underlying data. But we still have an escape hatch though. So there is a bytes accessor and a byte count getter, which tells you how many bytes the internal storage of the string have. Because at the end of the day, there's always a reason somewhere to access the raw bytes. Maybe you want to write them out to disk, or you want to just send them over IPC or something like that. So we do have a way to access the bytes, but operator square bracket is gone. There is no length because, at least in my opinion, having a string length API is ambiguous at best, because it sort of lulls you into this false sense of security that, oh, this string has length 3. That means that it has 3 visible characters, which may or may not be the case, right? Like depending on if the code points are the kind of thing that you can display as one visual unit or multiple. And it's just I think the string.length is not, it's too ambiguous. So we got rid of that. And really, there aren't that many places that need to look at the byte count, even, as I was saying, like the byte and byte count API. And we can probably have have it return a span, actually, instead of a raw pointer like it does now. But yeah, I think that will be good. It's going to force us to go through the exercise of writing better code in a bunch of places. Like we have to improve our parsers to deal with Unicode code points, instead of just being happy-go-lucky ASCII parsers that fall apart if they encounter something non-ASCII. But that will be good for us. Very good for us. Anyway, and then another thing that was really weak in deprecated string is that it has a null state. And that has been a source of confusion since, well, basically since the first non-me person started working on Serenity. So the thing is, deprecated string there's an empty string, but there's also a null string. And the null string is sort of used to signal, oh, there is no string here. And if you do a default construction of a string, you get a null string, not the empty string, but a null string. And the, deprecated string. And the null deprecated string pointer to characters is null, which confuses people sometimes. And what we would really like to have is to say, oh, well, if you need to signal the absence of a string, just wrap the string in an optional. And a bunch of our newer code in Serenity does that already. Despite string having a null state, we just use optional string anyway, because it's just much more expressive and everybody can understand what optional string means, whereas basically everybody has to learn the hard way what a null string means. So in the new string, we got rid of the null state. There is no null string. There is only string. And if you default construct the new string class, you get an empty string. So a 0 length empty string. And then you can wrap that in optional if you want. And we'll do some kind of trickery so that an optional string does not use any more memory than a plain string. That I haven't done that trickery yet, but that should be able to, we should be able to do that with a specialization of the optional template. Because there's bits available in the string. And then something else is that the new string has a small string optimization, which means that for any string that is 7 bytes or less on 64-bit or 3 bytes or less on 32-bit, we will be able to pack all of those bytes where we would normally store the pointer to the heap allocation with the bytes. And that effectively means that strings shorter than 8 bytes on 64-bit don't use a heap allocation. And this seems very profitable, at least with my initial testing. For example, I think it was something like 50% of the strings on Twitter, when loading Twitter in our browser, were 7 characters or less. So we're able to not heap allocate just an absolute boatload of strings, and you get better cache locality and everything, and it's just really, really nice. The cost of that is like a little bit of complexity and a little bit of branching internally in the string, but to the outside world it appears the same. Like you don't have to be aware of this as a user of the string class. So I like that a lot, and we'll test it out. I remember when I worked at Apple, then they did something like this with NS string or CF string or whatever at some point, and it was also like massively profitable across the whole system. So it's something I always wished that I would have done with our string class, but never looked into, and it just came about now because I was trying to like remember all those things I ever wanted to do with strings. Yeah, so small string optimization. 3 bytes on 32-bit is less exciting, obviously, but that's what happens because the pointer used for the heap allocation is smaller, so you can only fit 3 bytes of characters and a length in there. But it's still something, you know, and I think it's still nice to have uniform code paths instead of diverging. Of course, it's not entirely sure that we will keep 32-bit platforms for much longer, but for now I've implemented it for both. So yeah, that's small strings anyway. And then another thing brought on by memory profiling Twitter is that I've added a new way to create substrings. So traditionally, like the way that our substring API works is that you call substring on a string, and it just gives you a new string with a copy of the sliced out window of characters that you asked for. The new string class has an optional API with a scary name, so that you have to explicitly use a scary sounding API. But if you do that, you can get a substring that points into the superstring that it came from, but it doesn't actually deep copy the bytes. And this is risky, right? Because it means that the substring will keep the superstring alive. It adds to the ref count of the superstring, but it's very, very powerful in situations where you know for sure that you have to keep the superstring around anyway, and then you can have substrings that point into the superstring without making copies. And that's something that happens in our browser, because we have to keep source code for the JavaScript source code stays around in memory anyway. And then we have all of these like string literals and various like parse tokens and things like that that today use up a lot of memory. And now they can just become sort of view pointers, strongly ref counting view pointers into the original source code that is still kept around anyway. So that just eliminates a ton of allocations. It's in the double digits of megabytes on many web pages. So I'm looking forward to that one. But yeah, as I mentioned, like it is risky, right? It is risky to bump the ref count on the superstring, because you're potentially keeping a much larger string alive longer than you need to if you use the API incorrectly, or in a way where it would otherwise be possible to deallocate this large superstring. Now you're persisting it for longer. But I think the technique is powerful enough that it's worth having a spooky sounding API for it, and then allowing people to opt in when they know the risks and the trade-off that they're making, right? So definitely looking forward to that one. And one thing that the new string does not do, which the old string did, was that the new string does not guarantee null termination. So when I put together the first deprecated string, now called deprecated string, I made sure that the internal allocation always had a null byte at the end, because I thought, oh, well, that'll be convenient when I'm calling C APIs. And this was like back in 2018, and I didn't have a clear picture of how the system would come together. I just had a vague vision of what I was trying to do, but it wasn't entirely clear. And it seemed to me at the time that null terminating string storage just made it convenient to use them. And it has served us well in many cases, but I think it's the new string doesn't do that because, for one thing, I wanted to get rid of the sort of characters type APIs where you're asking for characters and treating it like any other sequence of ASCII characters. But more importantly, the null termination thing stood in the way of the substring that references superstring technique, because if you are able to create a substring that references the superstring but doesn't deep copy the bytes, there would have to be a null byte at the end of those substrings, which I would have no way of inserting, right? Because that would damage the superstring. Anyway, I think I've gone through the changes now, if I remember them all correctly. I may have forgotten something, but yeah, so allocation is no longer assumed to succeed at all times, so you have to actually handle or propagate allocation failures. And there is no null string, so if you want the absence of a string to be representable, then you need to wrap it in optional. There is no characters or length API. Instead, you have to iterate over code points, or in the future, grapheme clusters, whatever. And there's a small string optimization. There's the substring with a shared superstring optimization. And I'm probably forgetting something, but I think I've managed to cover the important parts. And I guess the one thing I just barely touched on was that the new string is unambiguously UTF-8. So it's possible to jam non-UTF-8 data in there if you really try, but we try to make APIs that just sort of steer you towards doing the right thing. And I would like to find out if there's more we could do, like if there's some way that we could, for example, have the compiler prevent you from instantiating something with an invalid UTF-8 input or something like that. Maybe we could use the UTF-8 literals in C++, for example, somehow to that effect. But yeah, some details remain to be figured out. Anyway, so with this thing in place and the old string now being deprecated string, it's going to be a bit of a journey and a bit of a hassle to convert code. Yesterday, I was prototyping converting Windows Server to use the new string instead of deprecated string, and it's straightforward, but it is a bit of a hassle. It's grunt work, but I think with the right helper functions and sort of convenience functions for converting between deprecated string and the new string, it will be reasonably straightforward, I hope. And the end result of all this is going to be that we have a much stronger string class with a better API, as safety, which means that like it can handle out of memory conditions, and it will be ready to integrate with Yacht because it has the same properties as the string does in Yuct. Yeah, and I guess something that this makes me think of is the way we use strings in the kernel. So we got rid of strings. We got rid of deprecated string in the kernel like a while ago. It feels like a year ago now or something, because they were not trustworthy, because they assumed that allocation would succeed, and then they would throw a hissy fit if allocation failed, and basically just panic. So we got rid of deprecated string in the kernel and replaced it with this thing called kstring, which has served us well, but I wonder if there will be, if it would be nice to make the new string fit well into the kernel as well. I'm not sure. There are some properties that I haven't touched on at all, which is like using the string in a multi-threaded scenario. So neither deprecated string nor the new string are thread safe. So they rely on you doing some kind of external synchronization if you want to share them across threads. But it would certainly be possible to add some little tweaks so that you can use it in a multi-threading scenario. It would be necessary to do it in the kernel, I think. At least the reference counting would need to be atomic and safe and so on. But that remains to be seen. Got the local police driving by here. Hope everything's okay with everybody. Anyway, I think that's the end of my train of thought. So thank you for listening to me try to explain the best I can about the new string. And I hope that the migration is going to be, well, not painless, because that's an unreasonable wish, but I hope it will be valuable and profitable to our programs. And I think it will be. And I think it will give like strong benefits just by itself in our C++ code base, and the fact that it will open us up to using the memory safe Yuct language going forward in the future, I think that will be very profitable as well. So I am excited about it. This is the most excited I've been about such tedious grunt work in a long time. Anyways, thanks for hanging out with me in the car, and I will see you all next time. Bye.